University Administration Education Bureau. Teach you grade 8 mathematics. Okay, so this is a second lesson, which is a continuation of the previous lesson. In our previous lesson, we have discussed about the concept of natural number, right? And we have also seen some other terminologies related with rational numbers like numerator, denominators, and other forms of fractions, right? The other thing related with the first lesson, I have also given a homework regarding the concept of natural number, right? I mean, regarding the concept of rational number. I hope you did the homework. Today, we will start another lesson, which is a continuation of the first lesson. Okay, so in our today's lesson, we will discuss two main points. The first point is about the relationship between four different sets, such as natural number, whole number, integers, and rational number, right? The other point of discussion that we will have today is the concept of the absolute value of a rational number, right? So these are the points of discussion for today. Stay tuned. Okay. The relation between natural number, whole number, integers, and rational number. Okay, so this is the first point of discussion for today. Okay, so we have seen different number systems in our previous discussion. Okay, the first set of number is the set of natural number. Okay, do you remember what numbers set of natural number contains? If you say 1, 2, 3, and so on, you are right. So the set of natural number contains numbers such as 1, 2, 3, and so on. Okay, this is the set of natural number. The set of whole number contains numbers such as 0, 1, 2, 3, and so on. The third set of numbers that we have here is capital Z, which is a notation that we use to represent the set of integers. So the set of integers contains numbers such as negative numbers, negative 1, negative 2, negative 3, and so on, and whole numbers, right? So this is the set of integer. Okay, the last set of number that we have here is rational number. Okay, the set of rational number is a collection of number having the form A over B, where these A and B are an element of integers, right? So A and B are an element of integer, and this B should be different from 0, okay? This B, or the number which is written on the denominator, should be different from 0. Otherwise, the fraction A over B will not be defined, right? So these are the four different sets of number that we have seen in our previous class. Now, in our today's class discussion, we will try to form a relationship between these four sets of number, right? So to create some sort of relationship between these sets, we need to apply a certain operator, which is called subset or proper subset. You can use both of them, but for the time being, for the sake of connecting these four sets using a certain operator, I will use subset, right? So what is a subset? Okay, from your previous class level or from your previous grade level, you have the concept of a set, a subset, and other related issues regarding set theory, right? Just to remind you what subset is, if we have two sets A and B, if we have two sets A and B with some element, for example, if set A contains a certain elements such as 1, 2, 3, and say set B contains an element with 1, 2, 3, 4, 5, right? Clearly, this set A contains 3 elements, right? Set A contains 3 elements, 1, 2, 3, and set B contains exactly 5 elements. Now, can you tell me what a subset means in terms of these two sets? If you apply the concept of subset by considering these two, A is called the subset of B, and it is usually denoted by A is the subset of B. Okay, this symbol is a symbol that we use to represent a subset, right? So what is a subset? A set A is said to be the subset of set B if every element of set A is contained in set B, right? So this is the concept of subset. Now, we will bring this concept into these 4 sets of number and create a relationship between these 4 sets. So, obviously, as you can see on these 2 sets, all the elements of natural number are included in the set of whole number. So, we can say that natural number or the set of natural number is the subset of the set of whole number, and we can write capital N is the subset of W. Okay, literally this means every element of set A, set N is contained in set W, but not the converse. Okay, you have to be very careful. We cannot say that W is the subset of N. You cannot say this. Why? Can you guess why we can't say the set of whole number is the subset of N? Because of the presence of this element, the number 0 is included in W, but not in N. That means if we say W is the subset of N, we are saying that all the elements of this set is contained in N. Due to this, we cannot say W is the subset of N. Okay, good. So, we can also create a relationship between these 2 sets, right? As you can see here, all the elements of whole numbers are contained in the set of integers. So, we can say that W, or the set of whole number, is the subset of integer, right? So, you can connect these 2 conditions together by writing this kind of relationship using subset. So from these 2 conditions, we can say that the set of natural number is the subset of whole number, and the subset of whole number is the subset of, the set of whole number is the subset of integers, right? So by connecting all these 3 sets, you can create this kind of relationship, right? Good. Now, when we go to the next set, the set of rational numbers, the set of natural numbers cannot be listed in this manner, right? There is no way to list out the first few terms of the set of rational numbers, because there is no clear pattern in the set of rational number. That's why we usually represent the set of rational number in the form A over B, right? For example, if you take 2 numbers, 0 and 1, between 0 and 1, you can find infinitely many rational numbers, right? So it's impossible to list out the first few terms because there is no clear pattern for the set of rational number. All right. So all these sets, the set of natural numbers, the set of whole numbers, and the set of integers can be included in the set of rational numbers, because every of these sets can be written in A over B form. Okay, if you take 3 can be written as 3 over 1, or you can make it 6 over 2. Okay, there are different ways to represent 3. Okay, 3 can be written in infinitely many different ways by writing in the fractional form, right? So all these 3 sets are included in the set of rational number. So we can add one more relationship. So this is the relationship between these 4 sets of numbers, right? Don't forget, every natural number is contained in the set of whole numbers. Every whole numbers are contained in the set of integers, and every integer is contained in the set of rational numbers. So rational numbers can be considered as a universal set for the 3 of these sets, right? Now, to make it clear, I will give you a certain example so that you will answer that question according to what I have explained here. Okay. So our first example regarding this relationship is give names or classify the following numbers as natural number, whole number, integer, and rational number. Okay, for the number that I'm going to write here, you will give a name and classify the given numbers as these 4 sets. For example, take a number 3 over 2, another number minus 11. The third number can be positive 10 and D0. Okay, now in this example, you are asked to give name or classify these numbers in terms of these sets. Okay, so if you take 3 over 2, is it a natural number? Obviously, this is not a natural number. Okay, natural numbers are 1, 2, 3, and so on. But 3 over 2 is a number which is found between 1 and 2. So we don't have any natural number between 1 and 2. So this is not natural number. Is it a whole number? Definitely, this is not a whole number, because you know what whole numbers are: 0, 1, 2, 3, and so on. So this is not natural number. This is not whole number. This is not integer. Okay, it can't be the member of these 3. So the only naming or the only classification that we can give for this number is an element of rational number. So you can say this is rational number. Okay, this is rational number. Whenever you go to the second number, minus 11, is it natural number? It's not, because natural numbers are positive. So there is no negative natural number. So this is not a natural number. This is not a whole number, because whole numbers starts from 0, 1, 2, and so on. So can it be an element of integer? Yes, of course. It's an element of integer, and it's also an element of rational number. Every integer is a rational number, right? every of these three sets, every members of these three sets can be the member of rational number. So minus 11 can be considered as a rational number and integer, okay? You can give a naming for this rational number and integer, right? When we come to the C case, in C we have number 10. 10 is obviously natural number. It's a whole number. It's integer. It's rational number. So we can give naming natural number. Let's make it short. So I'm using the well-known notation for natural number. So capital N, W, Z, and Q, right? So 10 can be the member of all those four sets, right? When we come to the last one, 0, do you think 0 is an element of natural number? Not. It's not an element of natural number. But 0 belongs to the set of whole number. It belongs to the set of integer and rational number, right? So this can be the member of W, Z, and Q. Okay? Students, now you have got the idea of classifying numbers in terms of these four sets, right? So this is all about the relationship between those four sets, right? Good. Now let's see the next topic for today. Our next topic is about absolute value of rational numbers. So our second point of discussion for today is the concept of absolute value of a number, a rational number, right? So before I go to the definition of absolute value of a rational number, I have to tell you what the absolute value of a number is. Okay, so in mathematical term, an absolute value of a number is defined as the distance from 0 to a number, okay, the distance from 0 to a number in any direction, okay? There is no consideration of directions, but the absolute value of a rational number can be defined as the distance from 0 to a number on a real line without considering the direction, okay? So this is the definition of absolute value of a number, okay? So if this is the definition, we can formally write the representation and the notation for an absolute value, okay? Usually we use this symbol, okay, this symbol to represent an absolute value, right? So an absolute value of a number x is defined into these ways, okay? We can define an absolute value of a number using piecewise representation. One of the value of absolute value of x can be x if this x is a positive number, right? The absolute value of x becomes x itself if that x is a positive number, and the absolute value of x becomes 0 if that number is 0, and the absolute value of x becomes minus x if x is less than 0, okay? We can define the absolute value of any number in this manner, okay? So, based on this definition, I will try to show you how you can evaluate the absolute value of any number, right? For example, evaluate the absolute value of the following numbers. Okay, now let's evaluate the absolute value of different numbers. For example, if we are asked to evaluate the absolute value of some number, say 7, the result will be 7. Remember, the definition of absolute value of any number is the number itself if that number is a number greater than 0, or if that number is positive, right? So, since 7 is a positive number, the absolute value of 7 is 7 itself, right? So, our answer will be 7. You may be asked to evaluate the absolute value of 0. Say, the absolute value of 0 is 0. Why? Based on the definition that we have here, the absolute value of x is 0 whenever that number is 0, right? The only absolute value that gives us 0 is 0 itself, right? There is no other possible value of x whose output is 0, right? Sometimes you may be asked to evaluate the absolute value of some negative number, right? The absolute value of negative number is also positive, because by definition, the absolute value of a number is the distance from 0 to that number on a real line without considering the direction. So the absolute value of -3 is positive 3, okay? Always the output cannot be negative, because by definition, absolute value of anything is the distance from 0 to some point. Basically, we cannot measure any distance using negative numbers. That's why the absolute value of anything, its output becomes positive. You can also take this one, the absolute value of -7 and 1/4, okay? Students, what do you think the absolute value of this mixed fraction? Based on the definition, the absolute value of this quantity should be positive, right? You have to follow the third pieces in the definition. So the absolute value of this mixed fraction becomes positive 7 and 1/4. So the answer for D part becomes 7 and 1/4. Okay, this is a simple question on the absolute value. Okay, now I will show you another example on how you can solve expressions containing an absolute value. Let's see the next example. In the second example, we will have some expressions containing an absolute value. So simplify or evaluate the following absolute value expression. Okay, the first expression here is the absolute value of 7 minus 19. The second one, the absolute value of 13 minus 5 plus some other number. And the third one is the absolute value of 5 minus 8 plus the absolute value of 8 minus 3. Okay, so if you are asked to evaluate this kind of absolute value expression, the first thing that you need to do here is you need to simplify the expression that are found inside the absolute value. So in A case, 7 minus 19 is clearly negative 12. So you need to put that thing inside the absolute value. So this becomes the absolute value of negative 12, right? So now, based on the definition that we have seen earlier, the absolute value of a certain negative number will be the negative of minus 12, which will be minus times minus. The result becomes 12, right? Positive. So the absolute value of the first expression in this example gives us 12, right? This is how you evaluate expressions containing absolute value. When we come to the second case, we have absolute value of something plus a positive number 7, right? So the first thing that you need to do here is you need to evaluate the expression that is written separately in the absolute value. So this is the same as the absolute value of 13 minus 5. 13 minus 5 is 8. So 8 plus 7, absolute value of 8 plus 7. Since this number is positive, its output is 8 itself. So it gives us 8 plus 7. The result becomes 15. So 15 is the answer for the B part, okay? When we come to the C part, we have two different absolute values, okay? You need to evaluate those absolute values separately, okay? When you see the first absolute value, here inside the absolute value, we have 5 minus 8. 5 minus 8 is minus 3. So you need to write absolute value of minus 3, okay? Plus, in the second absolute value, we have 8 minus 3. 8 minus 3 is obviously 5. So you can like this, okay? Now, we need to evaluate again these two absolute values separately, right? Then at the end, we will add them. So the absolute value of minus 3 is positive 3, as we have seen before. It's positive 3. And the absolute value of positive 5 is positive 5 itself, right? So this gives us 8. So the answer for the C case is 8. Okay, so this is all about simplification of expressions containing absolute value. Okay, we have also another kind of concept regarding absolute value. Next, I will show you how you can solve equations containing absolute values. Okay, so far we have seen how we can simplify and evaluate absolute value expressions. So next, I will show you how we can solve equations containing absolute value. Okay, equations containing absolute value. So the simplest form of equations containing absolute value is absolute value of x is equals to some number a. Okay, this is the simplest form of equations containing absolute value. Now, if this is the equation, we will have different solution type depending on the value of a. Okay, the first case is, in case one, if this number is positive number, the equation will have two solutions. Say this is equation 1, okay? If a is positive, equation 1 will have two solutions, okay? The second case is if A is 0, equation 1 or this equation will have one solution. In the third case for this equation, the third case is if this constant number is less than 0 or negative, this equation, okay, equation 1 will have no solution, okay, has no solution. This is the structure of the solution system for absolute value equation. So to make it clear, let's see a certain example regarding on how we can solve equations containing absolute value. Okay, the first equation, solve the following equations. Okay, the first one, absolute value of x is equals to some number 9. The second one, absolute value of x is equals to 0. And the third one, absolute value of x is equal to minus 3 and 1/4. Okay, now absolute value of x is equals to 9 whenever x becomes something. Okay, remember what we have said before. Absolute value of 9 is 9. Absolute value of minus 9 is also 9. Since A is positive, we expect two solutions for the first question. So this x can be minus 9 or 9. Okay, we will have two possible values for the first equation. If you make it absolute value of x is equals to 20, the possible value of x will be 20 and minus 20, right? This is how you need to respond for this kind of questions. When we come to the B part, we are asked to find the solution for the absolute value of x is equals to 0. In this case, the only x value that gives this result is 0 only, okay? So the solution set for the second case is only 0, okay? In the third case, absolute value of something is minus 3 and 1/4. Okay, based on the definition, absolute value of anything cannot be negative. And you can also consider the third case. So the solution set for the C part is empty set. So the solution set for here is empty set. There is no x value whose absolute value becomes negative, right? So this is the simplest part of solving equations involving absolute values, okay? In our next class discussion, I will show you a little bit stronger absolute value equations, and we will learn more about absolute value, okay? Okay, students, I hope you enjoyed the lesson. This is all for today. Thank you for listening.